Continuing with separating variables, we're going to look at this particular case when we're in the form dy dx equals some constant times by y. And looking into this, we need to know the words direct and inverse proportion. Now, if y was proportional to x, that means that y is proportional to x. That funny symbol just means proportional, which means y is equal to some unknown times x. If y is inversely proportional to x, that means that y is actually proportional to 1 over x, which means that y is equal to some unknown constant over x. So it's very good to know that inverse proportional means over, and proportional just means times. So we're going to look at two questions that involve this. Firstly, a laser cutter is purchased for $240,000. Its value depreciates by 7.5% per annum. Question 1, write a differential equation which models this scenario. So because it's going down per time, that means its value depreciates per time, which means we have dv per time, dt, is equal to, it's going down, so negative 0.075, which is the percentage, times its value. That will be our differential equation. Calculate its value after 4 years, while we now need to solve this differential equation. I'm going to divide by v to get 1 over v dv equals negative 0.075 dt, and then integrate both sides. That gives us ln of v equals negative 0.075 t plus c, which if I were to take the exponential of the right hand side, I'm going to get v equals e to the power of negative 0.075 t plus c. Now we looked at this in the previous video, but that can be written as e to the power of negative 0.075 t times e to the power of c, which simplifies to v equals a e to the power of negative 0.075 t. We now need to find a. We're told that it's purchased for $240,000. So that means that when t equals 0, v is equal to 240,000. So substituting those values in, 240,000 is equal to a times e to the power of negative 0.075 times 0. That means we have e to the power of 0, which is just 1, which means a equals $240,000. Which means we get v equals 240,000 e to the power of negative 0.075 t. When we have an equation in this form here, a is always equal to the initial amount, which is when t equals 0. So, calculate this value after 4 years. Now we just need to substitute t equals 4. V equals 240,000 e to the power of negative 0.075 times 4, which is $177,796. Part 3, calculate when it has depreciated by 45%. So that means it's gone down by 45%, which means that its actual value is 55% of its starting point. So let's find that value at 55%. Will be 240,000 times 0.55, or 132,000. So we need to know what is t when v is 132,000. So 132,000 equals 240,000 e to the power of negative 0.075 t. Well, we're going to divide by 240,000. That gives us 0.55 equals e to the power of negative 0.075t. We are now going to ln the left-hand side. Ln of 0.55 equals negative 0.075t, and then divide by negative 0.075. T will equal 7.9711, which is approximately 8 years. Question 2. A property speculator thinks that for a property, the rate of increase in value is directly proportional to the value of the house. Write a differential equation. Well, rate of increase of value, that's our d value over time, is proportional, so equal to k times the value of the house, kv. We're told now the property was first valued at $244,000. After 5 years, it is now worth $344,000. When will the house be worth $1 million? So we've got to solve this equation. Solving, we get divide by v, 1 over v dv equals k dt, and then integrate both sides. 1 over v integrates to ln v, and k integrates to kt plus our unknown, which means v equals e to the power of kt plus c. Now, once you've done enough of these questions, you don't actually have to write that line. You can go straight to a e to the power of kt. We know it's first valued at $244,000, so when t equals 0, v equals 244,000. So substitute that in. We get 244,000 equals a e to the power of k times 0, which means that that k will disappear. We're left with a equals 244,000. Again, the a is the initial value. So that means I have v equals 244,000 e to the power of kt. And when I'm solving for these unknown constants, I find it best to, as soon as I've found one, to rewrite that into my equation to keep track of what I'm up to. Then I'm going to substitute the other point. I've told that when t equals 5, v is 344,000. So that will help us solve for k. That means that we now have 344,000 equals 244,000 e to the power of k times 5. Divide by 244,000, we get 344 over 244 equals e to the power of 5k, which means that 5k is equal to ln of that. And so k is equal to 0.0687, giving us our final equation of v equals 244,000 e to the power of 0.0687t. Now, if you remember how to save values into your calculator, I would be saving this one into mine just to keep exact. When is it now valued at 1 million? So we're going to substitute v equals 1 million and solve for t. 1 million equals 244,000 e to the power of 0.0687t. Divide by 244,000, we get 250 over 61. It's e to the power of 0.0687t, which means that ln of 250 over 61 is 0.0687t, and so t is equal to 20.53 years. If you're asked to round to the nearest year, you'd then say that that would be 21 years, as at the 20th year we're not quite at 1 million.